Welcome to iPodcast Zone. And another deep dive. You know that feeling, right? You click a link, maybe type in a web address, and bam!
Yeah.
The page just appears. Seems like magic. Instantaneous.
It really does feel like that, yeah. But behind that curtain, oh boy, it's anything but instant. There's this incredibly complex journey your browser goes on, juggling loads of tiny steps.
Right. It's this whole hidden machinery. So our mission today is to sort of pull back that curtain. We want to unpack those steps, look at how your browser actually turns that simple click into a full interactive web page. Because understanding that really tells you, what makes a page load fast and feel smooth.
Exactly. And browsers are up against two main things, fundamentally. First, there's just the physics of it, network latency. Data takes time to travel. Can't avoid that entirely. And second, which surprises some people, is that browsers are mostly single-threaded. They basically have to finish one job before starting the next, which can cause some real bottlenecks if you're not careful.
Okay, so let's start at the very beginning. We've clicked the link. What's that absolute first invisible step before the server even knows we want something?
Right, that's the DNS lookup. Domain name system. Your browser have the name, like example.com, but it needs the server's actual phone number, its IP address, like 93 dot whatever.
That's full enough.
It should be, but think about modern pages. They pull in images, fonts, maybe ads, all from different places, different host names. Each one of those might need its own DNS lookup.
Ah, okay, so it adds up.
It really adds up, especially if you're, say, on a mobile connection that's a bit spotty. Suddenly, that instant lookup isn't so instant.
Okay, so DNS done. We have the IP address. Are we ready to ask for the page yet?
Almost. Next up is the TCP three-way handshake. Think of it like your browser calling the server. It says SYN, hi. The server says SYN, ACK, hi back, I heard you. And your browser says ACK. Okay, great. Just 3 messages to establish that reliable connection.
Okay, a quick hello?
But wait, there's more. If it's a secure connection, HTTPS, which most are now.
Which is good.
Definitely good. But it means another handshake, the TLS negotiation. This is where they agree on the encryption methods. And that adds 5 more round trips between your browser and the server.
5, just for the security part.
Yep. So add it up, the TCP handshake, the TLS negotiation, that's potentially 8 round trips before your browser even sends the actual request, like, get me the home page.
Wow, okay. That's a fair bit of overhead before we even see the tiniest piece of the page. So once the request is sent, what's the first bit of data we get back, and how do we measure that?
That first measurable moment is the time to first byte, TTFB. It's literally how long it takes from sending the request to receiving that very first chunk of data from the server, often just about 14 kilobytes.
14K.
Yeah, typically. And the browser doesn't just flood the connection. It uses something called TCP slow start. It starts sending data kind of cautiously, then ramps up based on how the network responds. It's trying to find the sweet spot, avoid congestion. Uses a congestion window to manage that flow.
Smart. So it's testing the waters while it starts getting the data.
Exactly. And the browser's super efficient. It doesn't wait for everything. The moment that first 14 KB chunk of HTML arrives, it starts working on it immediately.
So it's building the house while the truck is still delivering the bricks.
Pretty much. This is called parsing. The browser reads the raw HTML code and starts building a structure in its memory, like a tree. That's the document object model, the DOM. Every HTML tag becomes a node in this tree.
Okay, so it's building this DOM tree, but what about things like JavaScript? I hear that can slow things down.
Ah, yes, the script tag. That's often a biggie. Unless a script has a special async or defer attribute, when the browser hits a regular script tag while parsing the HTML, it stops.
Stops parsing the HTML.
Stops dead. It has to download the script, parse it, run it, and only then can it go back to building the DOM from the HTML.
Oof. That sounds like a potential roadblock.
It can be. But browsers are clever. They have this helper called the preload scanner. It kind of runs ahead in the background, scanning the HTML for high-priority things like CSS files, JavaScript files, maybe important fonts. It starts requesting those early, even before the main parser gets blocked by a script. Tries to get a head start.
That makes sense. And CSS gets its own structure too, right? Not part of the DOM.
Correct. CSS gets parsed into the CSS object model, or CSOM, another tree structure, but just for styles. This process is usually really fast, rarely the main performance problem. And behind the scenes, JavaScript is also being compiled, and an accessibility tree is built for assistive tech, like screen readers. Lots going on.
Okay, so we have the DOM tree, the structure, and the CSM tree, the styles. How do they come together to actually show something on screen?
They get combined into something called the render tree. Importantly, this only includes elements that will actually be visible. Stuff like head or elements hidden by CSS, not included here.
Right, makes sense. Just what we'll see.
Then comes layout, sometimes called reflow. This is the geometry phase. The browser calculates the exact size and position of every single box in the render tree, based on the styles and the size of your screen or window.
Like figuring out where all the furniture fits in the room.
Exactly like that. And this is where things can get recalculated. If an image loads late and doesn't have its dimensions specified in the HTML or CSS,
Oh.
the browser might have to recalculate the layout for part or even all of the page once it knows the image size. That shift you sometimes see. That's often a reflow.
Okay, layout's done. Now pixels.
Now pixels, that's the paint step. The browser takes those calculated boxes and actually fills in the pixels on your screen. That first moment you see content is often called the first meaningful paint.
And that needs to be fast for things to feel smooth.
Super fast. Ideally, each frame should be painted in under 16.67 milliseconds to hit 60 frames per second. Browsers can optimize this by putting complex elements onto different layers, kind of like in Photoshop, and painting them separately, often using the GPU.
Faster, but I guess that uses more memory.
It does. It's a trade-off. And if you have layers, the final step is compositing, putting those painted layers together in the correct order on the screen. And, importantly, a reflow often triggers a repaint and maybe a composite. It's all connected.
So the page looks loaded, everything's painted, we're done, right? Can I click stuff now?
Maybe. This is the crucial last hurdle, time to interactive, or TTI. TTI is the point where the page not only looks ready, but can actually respond to your input, a click, a tap, a scroll, within about 50 milliseconds.
And what usually gets in the way of that?
JavaScript, often. The page might look perfect, paint is done. But if there's a big chunk of JavaScript still running on that main thread,
The single thread we mentioned earlier.
that's the one. If it's busy executing JavaScript, it can't respond to you. So you tap a button and nothing happens. Or you try to scroll and it's jerky and unresponsive. That's what we call jank.
Right, that laggy feeling even after the page looks loaded. Very frustrating.
Terribly frustrating. It means even if TTFB and First Paint were fast, the user experience is still poor until that main thread is free.
So there we have it. It's quite the journey, isn't it? From that first DNS lookup, through handshakes, parsing, layout, painting, all the way to finally being interactive.
It really is a remarkable orchestration. So many complex steps happening incredibly quickly, most of the time, to give you that feeling of instant magic.
Makes you wonder, considering how complex it already is, what's the next big leap? How can we make the web feel even more instantaneous? Are there limits?
That's the big question developers and browser makers are always tackling, pushing those boundaries.
Definitely something to think about. Well, that wraps up our deep dive for today. If you found this look behind the web page interesting, please do like and subscribe for more insights right here on iPodcast Zone.